All right, guys, in the last video, what we were talking about specifically was it's extremely crucial that you understand what this test is doing and how it's operating, because it's important that you know the difference between your voltage leads and your current leads. All we did was we broke them out right here so that way we can use them individually. Okay, and so my blacks are my voltages and my reds are my currents. And this meter is not polarity sensitive. It will meter it in both directions. And so what we finished on was the fact that once you get to a certain point, you're only going to measure the voltage drop, period. It won't increase because you're not changing how much how much of conductor that you're pushing current through, okay? So now that we've gone through that, now I want to show you a really cool method for testing extremely long bus. And this really is a challenge for some people to comprehend, just because there's a lot of leads going on here, okay? But what you have to do first, and this is not a problem with your 100 amp ductors, your 100 amp contact resistance meters, they'll already have your voltages and currents separated out like this, so it's not a problem with those. All right, but what you're going to want to do is imagine that this bus is 2,000 feet long. I don't have 2,000 foot long leads. So how do I get to measure from this end to this end? That's what I want to do. And just so that way we're on the same page, I'm going to do a perfect reading right now, and I'm going to try to get you a number that we can all agree on that it's actually passing on, okay? And so I need this thing to stop. There we go. And so, all right, we're at 1340, and I don't have anything to write that down with, but we're just going to remember 1340. So that's the number we're shooting for, and that's going to be our check number, okay? So if you want to test this really long bus, what do we have to do? Now imagine this is 2,000 foot long. I don't have long leads. I'm going to test this bus all from one end, okay? I have leads long enough to test. Most bus bars are this, from A phase to B phase. They're right here in front of you. It's not a problem. So if you're 2,000 foot out and you want to measure every joint all the way, at every 100 foot interval, then the way to do this is you have to understand the test set. We are going to apply a current and measure the voltage drop, okay? So if I wanted to apply a current through it, I have to get a current through the entirety of this bus, okay? So how can I do that? Well, why don't I use the other phase as a return, okay? So that's what I'm going to do. I'm going to take this current, and I'm going to clip it right over here. I'm going to use this other phase as a return, all right? So now we've got that figured out. Actually, I'll move it towards the inside just because I want to be able to get that voltage clip on there. But we have to jumper this through, okay? So I'm going to go ahead, I'm just going to jumper this on here like that. All right. Actually, yeah, there we go. We're going to jump it on there like that. Now, the other thing that we want to do is we need a voltage. We need to measure the voltage drop. But if I bring this current back across here and I measure the voltage drop off of here, right? If I measure the voltage drop on here, it's going to be this one and this one. And I don't want to do that, right? That's not what we're trying to do here. Plus, I'm also measuring the voltage drop of these leads, and that's definitely going to be a bad test. So what do we want to do? We need to bring back the voltage on the other phase that's not being used. Or you could use your ground bar. That would work too. So what we're going to do is I'm gonna try not to fall over here, and I'm gonna clip this on here and here. Now, it's very crucial that you don't let your leads touch down here. And I know you can't see that. There we go. So I'll redo this. You've got your current jumpered from bar to bar, okay? And then you've got your voltage clipped in here as well. And this is gonna be your guy that's on the radio at the other end, 2,000 foot away on the bus, okay? So now you've got that handled over here, okay? And so now we're gonna go ahead, like I said, don't let these leads touch, all right? We'll demo that in a second, why you don't wanna do that. Now, if you come over here and you go ahead and you start testing, now we were shooting for 1,400 something, and we're gonna go ahead and see what we got. And we got actually a little bit better number than we had before. So, hooray to me. But still, That's how you're going to do it. Okay? 1340. Maybe that was the number. I can't remember. Regardless. Now that we've got that figured out, let's see what happens if we come down here and we hook up our leads wrong, okay? So I'm just gonna take my voltage clip off so that way we don't start running a test while we're moving stuff around. Now, what happens if you got the guy and he's out in an aerial man lift and he's doing this bus duct up in the lift for you or whatever, right? He's on a radio. You know how it goes sometimes out there. So, and he just goes over there and he just has, you know, a piece of wire or whatever, and he just jumpers all three of them to each other. Now what's going to happen, right? This is not going to be what you want. I can tell you theoretically what's going to happen. Your current's going to come through here and it's going to come across. It's going to jumper through this clip. It's going to come across this one, right? And so your voltage, you're still metering it off your middle bar. Well, what does the voltage see? What voltage drops does it see? It sees the voltage drop of this bar. It sees the voltage drop of this clip connection right here, which is going to be very poor compared to a solid bar. And then it's got this little banana jack. It's got some copper wire right here. It's got another banana jack, and then another clip connection, and then actually it stopped running current right here, so you don't have this clip connection at all. It's just all of this through here, okay? And then the current stops, so that's the only voltage drop it sees. So now we're gonna come back over here. I'm not gonna mess with anything, and we're just gonna run that just like we did before, okay? And what do we get? We get a really, really high reading, 4.9 milliohms compared to our, our much lower micro ohm reading that we had earlier. And so I'm going to go back and do one more micro ohm reading just like we had a minute ago. I'm going to put this across here. I'm going to take these voltages and put them. So we have 4.9 milliohms. And then we're going to go ahead and, actually I'll just do it like this. And we're essentially 1.3 milliohms, okay? So this is very thin aluminum bar, so that's why we've got a higher reading than you would expect with, you know, 1/4 inch thick, 2-inch wide copper bus. This is, like I said, very, very thin. So, but regardless, as you change where your voltage drop is, that number or that position is going to dictate what number you get, okay? So keep that in mind and don't let your leads touch. If they start touching, you start measuring the voltage drops of these little clip connections, okay? Thank you.